The world is facing a critical moment, tackling the climate crisis and moving towards net zero carbon emissions. While much attention is rightly placed on financing solutions and developing technologies like carbon capture, there's a foundational need that often goes overlooked: the raw materials themselves. Geologists and earth scientists are needed more than ever to find the critical minerals and metals required for cleaner energy technologies. Think of all those solar panels, wind turbines, and electric cars. They don't build themselves, and they certainly don't run on good intentions alone. The transition to clean energy is incredibly mineral-intensive. An electric car, for instance, requires significantly more minerals than a conventional gasoline-powered car. Technologies for generating low-carbon power, like solar PV, onshore wind, and offshore wind, also demand substantial quantities of minerals per megawatt of capacity compared to traditional power sources like natural gas or coal. Even the electricity networks that transport this clean energy across distances need minerals. This surge in demand for minerals like copper, lithium, nickel, cobalt, rare earths, and graphite is making the energy sector a leading consumer of these vital resources as clean energy transitions accelerate. So, where do these essential minerals come from? Finding them is the job of mineral exploration. It's a bit like a high-tech treasure hunt, a scientific process where each step depends on the results of the last. Geologists and prospectors look for concentrations of elements that are much higher than their normal levels in the Earth's crust, what we call background abundance. Geochemistry, the study of the chemical composition of the Earth's crust and its materials, is a key tool in this search. By analyzing samples of soil, rock, or even water, geochemists can detect anomalies, areas where elevated levels of certain elements might indicate a hidden ore deposit. Modern exploration relies heavily on technology to make this search more efficient. GIS, Geographic Information Systems, and remote sensing techniques are revolutionizing how we look for minerals. Remote sensing uses satellites or aircraft to collect data about the Earth's surface without actually touching it, picking up clues like the spectral properties of rocks or the presence of certain plants that might indicate mineralization. GIS allows geoscientists to layer and analyze various types of data: geological maps, geophysical surveys, geochemical results, remote sensing imagery to identify promising areas for exploration. It's like having a superpowered map that can highlight where the X might be buried. While each technique is useful alone, combining them is proving to be significantly more effective in pinpointing potential ore deposits. This integrated approach helps make mineral exploration more cost-effective, which is always a win. Once potential areas are identified, more direct methods are used to confirm the presence and quality of the mineral deposits. These can include trenching or costining, which involves digging ditches to expose near-surface rock for sampling and assessment. For deeper exploration, diamond drilling is used to extract cylindrical cores of rock from below the surface, providing geologists with a detailed cross-section of the subsurface layers and mineralization. Sometimes larger samples, known as bulk samples, are extracted to assess the nature of the mineralization on a bigger scale, although this requires government approval and environmental reviews. However, finding the minerals is only part of the challenge. Extracting them is another, often fraught with significant environmental and social hurdles. Mining, whether large-scale industrial operations or smaller artisanal endeavors, can have profound impacts. Let's look at cobalt, a critical mineral for electric vehicle batteries. The Democratic Republic of Congo (DRC) is a major global supplier of cobalt, with a significant portion coming from artisanal and small-scale mining ASM operations. These operations provide livelihoods for hundreds of thousands of individuals and support entire communities. Economically, artisanal mining can be very attractive compared to other local jobs like agriculture, sometimes serving as a crucial secondary income or primary source of survival in regions facing extreme poverty. However, miners in ASM often face significant income fluctuations and can still experience extreme poverty despite their efforts. Beyond the economic complexities, there are serious social and environmental concerns associated with mining, particularly artisanal mining. Issues like child labor, which gained international attention regarding cobalt ASM in the DRC, highlight the social risks. Environmentally, mining can lead to contamination of air, water, and food resources from dust particles and the extraction and rejection of toxic waste. While large-scale industrial mining is often the primary source of heavy metal pollution, artisanal mining also contributes, especially when communities live near larger operations or when toxic waste from processing is not managed properly. Research has shown alarmingly high concentrations of heavy metals like cobalt, cadmium, lead, and uranium in the urine of people living near mining sites compared to populations in wealthier countries. Managing environmental impacts, including controlling dust emissions and handling hazardous materials, needs robust environmental management plans that cover all phases of a mining project, from exploration to closure. Abandoned mines that are not properly cleaned up pose long-term hazards like collapsing tunnels and ongoing contamination. Water management is another critical environmental issue in mining. Mining activities can require substantial amounts of water, and improper water management can lead to contamination of surface and groundwater resources. Tailings, the waste material left over after the valuable minerals have been extracted from the ore, are a major concern. Tailings facilities, essentially dams holding this muddy waste, can fail catastrophically, leading to devastating environmental and social consequences as seen in past disasters. Finding ways to manage tailings safely and sustainably is crucial. Some controversial methods, like deep-sea tailings storage, are used in certain locations, but they are poorly understood and could threaten marine biodiversity. Facing environmental pressure, some regions have even halted deep-sea disposal. Given the increasing demand and the challenges of extraction, ensuring a secure and sustainable supply of critical minerals for the clean energy transition requires a multifaceted approach. Beyond traditional mining on land, some are exploring unconventional sources like deep-sea mining. However, the potential environmental impacts on unique marine ecosystems raise significant concerns, leading to calls for moratoriums from various groups. A crucial part of the solution lies in improving the efficiency and sustainability of mineral use throughout the entire life cycle. Recycling critical minerals from end-of-life products and manufacturing scrap is essential to reduce the reliance on primary mining. This includes recycling components from electric vehicles, batteries, and other clean energy technologies. Governments and policymakers need to redouble efforts to scale up all forms of recycling. Treating mine waste tailings to recover remaining valuable minerals or mitigate environmental hazards is also part of a sustainable approach. Some research is exploring the possibility of recovering rare earth elements from mine tailings, for example. Furthermore, promoting responsible sourcing and sustainable development practices in the mining sector is paramount. This involves ensuring transparency, addressing human rights issues like child labor, and minimizing environmental impacts. Initiatives like the OECD Due Diligence Guidance for Responsible Mineral Supply Chains provide frameworks for companies to identify and mitigate risks. Countries like Canada are aiming to become leading suppliers of sustainable and responsible minerals, leveraging their significant reserves and developing policies to promote responsible mining practices. They are also assessing their recycling capacity to support sustainability and competitiveness. In conclusion, powering the green transition requires more than just innovative technologies and financial investment. It requires a fundamental understanding of the Earth's resources and a commitment to finding and extracting them responsibly. Geologists are on the front lines of this challenge, tasked with finding the materials needed, while the entire industry and policymakers must work together to ensure these minerals are sourced sustainably and ethically, with recycling playing an increasingly vital role. It's a complex puzzle involving geology, technology, economics, environmental science, and social responsibility, a true Earth-sized undertaking. This summary is based on the Nature Geoscience editorial Minerals Power the Green Transition, located at HTS, doi, org 10 1038S415610240159112, expanded with information from the other provided sources.
Welcome to the world of geology and earth sciences with Ricardo Valls, a seasoned professional geologist bringing you over 650 videos of unparalleled expertise. Whether you're a budding graduate student, an early career specialist, or a seasoned professional, this channel is your gateway to a wealth of knowledge. Explore a vast array of Earth-related subjects, including geology, geochemistry, structural geology, and the application of artificial intelligence and machine learning in geosciences. Ricardo Valls not only shares his own invaluable insights but also brings you exclusive interviews and collaborations with other prominent geologists, offering a comprehensive view of the field. Stay ahead of the curve with our latest content, covering everything from unraveling the Earth's secrets to exploring global geological phenomena. Don't miss this opportunity to enhance your knowledge and stay at the forefront of the industry. Subscribe now, hit that like button, and share this invaluable resource with your colleagues and friends. Join our growing community of over 1,800 Earth science enthusiasts and professionals today. Unlock the secrets of the Earth with Ricardo Valls, your top resource for all things geology. The future of geosciences is here. Be part of it.
I think these videos are brilliant, and I'm sure you will like them too. Please like, comment, and subscribe, and don't forget to click the notification bell.